Can't think of the other thing. There was one other thing that I was concerned about. The last thing, has anyone ever tried to schedule an appointment for my office hours? All right, so if y'all could go in and try just to use the link and send me a screenshot of what happens when you click the link, that would be great. Just to show me if it works, if it doesn't work. That way we can start figuring out, because I have some students say it doesn't work, but yet I've had someone do it in front of me and it did work. So whenever you have time, that's just me asking a request and not forcing it. But if you have time, it's in the third module and it says appointment link for office hours. Just click it, and whatever that next screen you get is, take a screenshot to show me that either it did work or it gave you an error. That way we can trace like kind of what the issue is, or I could if there is an issue. All right, so any questions about stuff like that I can fix, though, that haven't seen yet. So okay, Canvas wise and everything then? All right, let me make sure I got my recording going. All right, so today we wanted to continue with what we worked on. We were talking a little bit before everyone got in here, is dealing with the idea. We did talk about linear functions and slope. Make sure you have those formulas down, okay? If you have further questions about those, please let me know. I may not always have time in class, but right now I think we still have at least one study date before our test. As far as in-class study review session, okay? I'm doing my best to keep it that way, but that's kind of the path one, so let's keep that in mind. But we do need to continue with graphing. But what do we notice about these graphs that I've given us here? As you look at these four functions, what's something that we should notice? Are they all the same function? No, right? That we're dealing with a variety of functions, right? If you wanted to, you can sum it up in one word. They're all non-linear functions. That clear to everyone? If you have a linear function, the choices I would give you for graphing that would be, one, to use intercepts, or two, to use slope in the y-intercept. Those are great ways to graph it, okay? And that's one thing I hope we got caught on to, like when we talked about these two here. I specifically focused on plot your y-intercept and go from there. Right? If it's already in slope-intercept form, that's nice, because then we can use the slope to get from that y-intercept to a second point. All right? And I shared that you could also go from there. You could go backwards with it to get a second point, because the slope is the same no matter what 2 points we pick. Here was a special case now, because remember, you could have vertical or horizontal lines. So that's one thing to watch out for. Now, as we move forward, though, with these other functions, right, we want to be careful that we recognize first and foremost what type of function it is and how we should proceed to work with that. So as you see f of x here, what type of function is it? Now, on the test, you wouldn't necessarily have to write this out, but I usually ask for the parent function. So instead of writing out absolute value, another great way is just kind of, hey, this is the most basic version of that. That's another way to write that, hey, I recognize this is an absolute value function. Just put it in the most simplest form we can. We have one x to the top. Well, if it was just x, hey, we can go look at this graph and say, we know that this graph looks something like this. Oops. And what was the shape of an absolute value that we take from that? A V shape, right? That's kind of what we take from. Now, what we talked about yesterday, though, is, hey, this function's got a little bit more going on, right? When we look at f of x, there's a little bit more going on than just the absolute value of x. Specifically, what is there that we should talk about? The -3 is definitely one of the things we have to talk about. What else? The +7, right? Now, make sure you see here when you say that. I like that we said, hey, it's +7, right? And it's -3. When you're adding or subtracting stuff to a function that only has that one variable, right? It's not an x squared or anything, it's just x. We can use what we call transformations, okay? Now, as far as transformations is concerned, we're saying that this affects the shape of the graph or the position of the graph. Those are the two things that can happen, shape and position. All right. What do these two things do? So is that a shape change or a position change? A position change, right? So let's focus on the -3 first, since that was stated first. What does this say that I should do to my graph when I go to draw f of x? Right, so that's good. We need to see here that that -3 represents a shift down 3, okay? With that in place, go from that origin point. It's not a vertex, but it's similar to a vertex. So if you say it, we can get away with it. The only person I would say be careful would have been Mason, who said he has to take calculus, right? Then we can have a whole another conversation. For us, though, hey, find the bottom of the V. That's where we can say, I know this goes from 0 down to -3. But we're not done there because we have the +7, right? What does the +7 tell us to do? All right, so I heard a little bit of a different thing here that we have to be careful of. First and foremost, it's just a position change. Does everyone see that? As a -3, just hey, bring it down. The 7 is going to move it left to right now. But I heard left and right just now. All right. So, but the key is if you ever get stuck, what can we do? Take whatever's on the inside, right, and set it equal to what? 0. That's the key. Now, all we're saying is there, what would I have to do to get the absolute value of 0? That's kind of what we're saying. That's another great way, though, to kind of make sure to remind yourself that, like, okay, I do the opposite. All right. Which I totally put the wrong coordinate plane here, but we'll make it work. There we go. We're going to make it work. Okay. But hopefully what you see here is the first thing I did was that down 3. And now we got to go 1, 2, 3, 4, 5, 6, 7 to the left. What do I put at that spot that we just got to? And what point will that represent on the graph? But as we look at the shape of the graph, that's probably a better way to put it. What point does that represent on the shape of the graph I need to draw? The bottom of the V. Now, keep in mind, if we have a reflection like we talked about, could be a minimum or maximum situation. We're going to make sure to talk about that as we go through these, that there is no reflection here. So we should know kind of, okay, that's going to be the minimum value of my V. Okay. With that said, then there's no other transformation, so we can confidently just draw out the same graph that we did before. And what I mean by other transformations, we didn't have any multiplication or division involved. Okay, because I could put if I wanted to, we could do something like, hey, let's put a 2 right in front of the absolute value. All right, and that's where you're going to start to see the shape of it change. It's still going to be a V, but it won't be just like what we started with. All right, and as I put a 2, guess what? We could put 1/2. Okay. With that said, though, if you get stuck, just remember when I zoom in here, if this is compared to 0, 0, well, this is up 1 over 1 because the absolute value of 1 equals 1. That's where we come from with that. Okay. Now, if you get stuck, though, the main point I said to focus on is that point there. All right. If you get stuck and you're not confident with the shape aspect, take your chart and say, hey, I'm going to have X and I'm focusing on my function, not the parent function. That's going to help us. But I'm just going to go back to my function. The one point that you have to get in place is that point that we call like a turning point of the graph, right? The bottom of the V. From there, what X values could we plug in? Everyone understand why we picked those points? And hopefully what you catch on was we went, that's the middle point, right? And just go 2 in both directions. what you'll find is if you do that, it will give you the shape you need. You don't have to just guess and check in that sense. But the key is we have to be comfortable with the transformations and what to expect. In this case, we need to know, hey, that's my turning point of this graph. I definitely need to get that in place. Okay. I didn't realize that was off the screen. Sorry. Do I write off the screen a lot? Are we okay with that though? Is there any concerns I can clear up here? All right, but some things that I would make sure to point out here when you start doing these, make sure you start by identifying what you're working with, okay? Oftentimes on the tests, and I know on the final they do this, it'll say graph the parent function and the function you're working with. So that's why you see here, I just put both of them on there. This gives us just a good quick reference to remember what we're working with when I go to put this actual graph in place, okay? What was the next function though? Are we good though if I just put P of X equals X squared? Now remember, I'm just picking P though to say, hey, this is the parent function. That's what sets what we're working with. That's all I'm doing there. All right, so what transformations would we say is going on here?
Horizontal would be right one.
What is the key though that should be a horizontal shift? The squared is definitely a big part of that, right? Specifically, what symbol is there with the square? The parentheses, right? That's definitely the part that we need to make sure that we see like, hey, these parentheses are here because of the squared, right? So whatever's on the inside of those parentheses represents what we're working with, okay? Absolute value is nice because we have those symbols. Square root's nice because it's all under the radical, right? Sometimes when you have parentheses, though, you got to make sure you stop real quick and say, okay, why do I have the parentheses here? Because if I have a square, no, I could put a cube out there. We could put any other exponent we want. So we have to be careful. Any concerns, though, with where the right 4 is coming from? Is there anything else we got to talk about? What was that? We need to talk about that one? It is out front, right? So out front means then we're focused on vertical. What does that mean though when I multiply by -1? It flips the sign, but ultimately it's going to flip all of them, right? That's where we came in with that word reflection. And when you multiply by that -1, it's a reflection. Now, remember that negative is right in front of the parentheses. That's how we know, hey, this is -1 times this. Okay. But as you said, it changes the sign. What that's going to do, though, is take my graph that we see here, and that means I'm going to flip it over the x-axis. It's a reflection over the x-axis. Now, you can say reflection over the x-axis, but hopefully what you're seeing here, as long as I noted that it's a vertical reflection, we're kind of along the same terms and knowledge there, okay? With that said, though, the only thing we did as far as position changing was to the right 4. So I could put that first point there. The key is when I go draw my parabola, we need to make sure we draw it which direction. And do we all follow that though? And if you're not confident with the points, what did I say we can do to get these points to ensure that we see where it's coming from? Right, build the table though, right? And so to make sure that we stay consistent, what's the one point that we need to put on this table? 4, 0, good. Right, that was that transformation, right? Hey, all we did was shift to the right 4, so my y value is still on the x-axis. what we find is now it's just an x-intercept, not both, because if it's origin, it's an x-intercept and a y-intercept. So be careful on that in the homework. If you ever get the origin, remember that's x and y at the same time, okay? But from here, as we talked about, just make sure you plug in the points around it, and you should be good to go, okay? I usually say make sure you get all 5 points, but also remember we talked about what's true about quadratics. They're their functions, good, right? But why did I draw my vertical line right there? There's symmetry, right? It's not an even function, right? Because it's not with the y-axis, but it is symmetry. Yep. Talking about here, right? So was there anything added or subtracted on the outside of this problem? No. So where does that point start at originally? 0, 0, right? So whenever you get here, remember, hey, I'm applying that to 0. So to the right 4 is positive, right? So 0 plus 4 is 4. There was nothing to shift this up or down. So it stayed at 0. So it's always start with, now this is for quadratics and absolute value, right? Start with 0 and then move forward. It gets more intense though. Remember, as we talked about, there are some exceptions. Why do I not start with 0 on this one? So as we look at this function, why is it I said don't use 0? What type of statement is this? So rational, right? And what do we not want in the denominator? 0. So that would be one like instance where be careful because we do have exceptions here, okay? But as you can see here, the absolute value, square root, cubic, quadratic, linear, that's one of the nice things. Hey, I can start with the origin. So if you don't have anything, just remember, okay, it stays at 0. Does that help? We'll talk about other functions that have similar things called exponential and logarithmic functions, but that's when we'll get to that later. Now I lost one. Here we go. The exponential and logarithmic, though, that's going to be the 4th part of our course, but you'll see those don't go through the origin either, but we'll have that conversation later, okay? Any other questions or concerns? So I guess just to make sure to conclude, then make sure you remember here, this starts with the origin. And then our transformations is what we applied to get to that new. Okay, so keep that in mind. We're good though with the quadratic one. Nice thing, hopefully you caught on here with the absolute value quadratic. I just can do the next points, right? Plug in 2, 3, 5, 6, and I get the 5 points I need. Okay. My other hint was though, when the nice thing about quadratics and even the absolute value one, it's not even, right? If I plug in negative x, it won't help me, but the graph itself still has symmetry. So if you remember that, just focus on those 2 points and copy them over. Okay, it's another great way to do that. What's different about this one? All right, so this is another one, but this is that special one that we have to remember to start at the origin and go from there. This one definitely has a special case because like when we look at this has a domain restriction where we don't want negatives. Why don't we want negatives though? All right, we don't want any I right now. We don't want those complex numbers, okay? I would encourage you anytime you get the square root of something, make sure you state that first, right? Just like rationals, as we just discussed. When we did rational equations, I said, make sure you state restrictions at the beginning. Don't wait to do that. Okay. Those are the 2 things that we have to watch for at this moment is x in the denominator and x under a square root. Cube roots are different. A square root, though, I don't want complex numbers. Okay. With that said, what are some of the things that someone sees here for the transformation? Do we all agree with no horizontal transformations though? What are we looking at to see horizontal? Right, so our focus goes to the square root itself, and all it is X, right? So, hey, good job. No, nothing's going on horizontally. However, what's outside the square root?
A negative.
A -2, and is someone else a negative? We do want to distinguish this differently though, right? Because the -2 represents one thing, and the negative right in front of it, as we just talked about, is a what? Very good. Now, as far as your work is concerned, you don't have to put times -1. As long as you see here, I'm trying to show you a nice kind of shorthand way to write this. Vertically, we have a reflection. Is the key there. Now, in the homework, you have to make sure to put it in the way they want it typed in. So please be careful when you go to the homework to type it in correctly. A couple of the problems on my open math assignments I gave us, was it last week? They might just be kind of like select the ones that are true. But be careful on Pearson to put it in as they want it in, right? I think as someone mentioned yesterday, what was reflection over the x-axis would be what this is. But just remember, hey, x-axis is horizontal, so if I reflect it, that's vertical. Okay. What's the -2 representing?
Come down.
All right, so that's the nice thing about a vertical shift, right? Just do what it says. But as we saw with that previous problem, that means I'm starting here. Okay. Now, this is a unique one, right? So as long as we remember the domain situation that we don't want negatives, right? We stated that right away. We know where to start already. So right away, we should be plugging 0 for x. What are we going to get when we plug in 0 for x? How far did you just say to go down? There we go. Now, this is where it goes back to make sure you state your domain first so you know what x value to start with. From here, though, what is special about the square root that we don't want to forget? Oh, what was that? Yeah, make it easy on yourself, though, right? You could plug in whatever number you want here, but make it easy on yourself, right? Let's use perfect squares. The nice thing, since we're starting at 0, we could just use the perfect squares as they are. But know that if you had, like, say, x plus 2, well, what would you have to plug in to get 4? So if you have x plus 2 and you want to use 4, remember, hey, I got to actually plug in the value of 2, right? So you might have to plug in something else to get there, but let's make sure we focus on it. But here, the nice thing is I could just plug in 1, 4, 9, 16, and so on, okay? With that said, though, if you follow the graph, why am I drawing it this way? All right, we're all okay with that reflection? And understand, again, if you take the table approach, that's another great way to do it. Just make sure you're hearing me out that this point is definitely an important point to start with. Okay. I will say one of these things, the more you practice with something, the more you build your confidence with it. That's what it boils down to. Okay. Sometimes the homework assignments aren't enough to help you feel confident about it. So keep that in mind too. Okay?
Very tedious like when you put in the
and that's why I always draft stuff by hand. I get that, especially because like Pearson made changes that have never been explained to me. So the only thing I could do is say, hey, if you come in here and work it out in front of me, then we can kind of walk through it. So, because even with the quadratic, when I messed with it, I was like, okay, there's no clear way to understand how to do this. And there was a lunch and learn today, but I couldn't make it because guess what? We got class. Do we feel okay with this one though? All right, so this is a big difference though, okay? So put a highlight on this one. I will say on this is knowledge purpose, all right, because it is a big difference. Each of the first 3 graphs, hopefully you caught on, it was just a positional change of the graph. It moved the origin point or reflected the graph itself. It's just the shape though was the same shape we started with. However, what does someone notice about this one while they're writing it down? That's a big difference. So I heard +1, -5, but that 2 out front is actually the one thing that we need to just kind of briefly talk about today. What does that do? It is a transformation, yeah. What you're going to find is though, as I draw that shape, when I go deal with this 2, the shape is not going to be the same. So that's why we want to make sure we look at this and we're comfortable with it. All right, so if I start there, are we okay with where I'm getting that from? Is there any concerns where I'm getting left 1 and down 5? So if I put this, then are we good? Now, what happens is this is where we have to be careful because we don't need to stop there, right? We have to make sure to say, hey, we covered the positional changes that took place, but now we need to talk about this first one here that represents now a special transformation. All right, and let's think about what that does though. All right, what is 0 squared? 0. What is 2 times 0 give us? 0. So positionally for that, the vertex, it does nothing. But when we get to 1, what is 1 squared? 1. But 2 times 1 is now 2. So what we're seeing here is that's actually going to affect the graph when it comes to dealing with those output values in a big way. All right, and this is where we're going to get into a place where we're going to talk about stretches and shrinks, and it actually affects the shape of the graph. A stretch, what we're going to see here is going to take that graph and make it look more narrow, being a vertical stretch. Let me make sure I'm clear. This is a vertical stretch. A shrink is going to take that graph, and that did not show well at all. Give me a second.
So, how do you know if it's vertical or horizontal?
Well, because of what it does to the graph. That's the first thing I'll say here, and we'll plug in points with this one just to see. Okay. So what you see here, this is going to be the stretch. The stretch is narrow. Like does anybody have a rubber band? I always forget to bring rubber bands for this class. Take a rubber band and hold it vertically, right? Kind of have it as a circle, right? If I pull it vertically, what happens? They get closer together, right? Does everyone see that? That's where that idea of a vertical stretch is squeezing together. The vertical shrink though is if we take that same rubber band holding it vertically and push our fingers together now, the sides of the rubber band are now going to get further apart. So that's a great like reference point, just hold it vertically. Now understand that as I talk about this from a vertical perspective, you could also have horizontal stretch and shrink. Okay. The one thing that I will say that gets messy about this, there's always a way to rewrite something. Okay. One of the few problems that you can see like a definite distinction on would be something like, say, the square root problem, all right, where some of the ways that we manipulate are a little bit tougher to work with. Okay, but there's almost always a way we can rewrite a problem to where a horizontal stretch or shrink can also be from the perspective of vertical stretch or shrink. So that's why I'll introduce it. It's on the homework. Make sure you take the table approach if you get stuck. But I feel it's still good to talk about because, hey, guess what? We do have other things. Multiplication and division definitely impact our graph. Okay. Now from here, as you saw, I did the parent function. I just did a quick example of if it was just a stretch or just a shrink. Okay. So make sure that when you look up here, that's just kind of what it looks like. It's still a parabola. It's still a U shape, but it doesn't look like the one we've been working with because it's either narrow or wider. Okay. That's what we're working out. Now, with that said, Make sure you see here that we would call this a vertical stretch. And the reason we call it a vertical stretch is because 2 is bigger than 1. We looked at -1. 1 doesn't do anything, right? But the second we have something bigger than 1, that's a vertical stretch. And we would say, hey, stretch by a factor of 2. Or you could just put stretch by 2. The word factor is important though, because it's just insinuating that we're multiplying everything by 2. Okay. Now, with that said, if a number is between 0 and 1, that's going to be when we call it a shrink. So if the number is bigger than 1, it's a stretch, but if it's between 0 and 1, it's a shrink. Do I need to worry about negatives? I'm about to fix that, sorry. I keep So keep in mind, like 2 is bigger than 1, so that's a stretch. But if I threw something in there, like say 1/2, that's all of a sudden less than 1, it's a shrink. Okay. We wouldn't use 0 itself because 0 would get rid of that stuff altogether, right? 0 times something squared, I don't even have it anymore. Okay. Why didn't I talk about negatives? What would a negative imply? It's its own thing, right? A negative, it's its own thing. It's a reflection. So like if I came over here and did this like as, hey, -2 times x plus 1 squared, you would then need to say, hey, this is 2 transformations. That's 2 separate transformations taking place. You would say that, hey, this is -1 times 2. So there's your reflection and there's your stretch. All right. So keep that in mind.
It's a horizontal distance.
No, it would still be vertical because it's on the outside. Right. So just as we saw here, it's on the outside. So we would just call it a vertical reflection. Huh? It's on the inside. That's correct. Which, like I say, like you will have horizontal transformations as stretches and shrinks, but sometimes it gets messy because I can rewrite something. Imagine I gave you something like this. Right. What you would say there is, hey, that 1/2 is our what's affecting this graph. Now remember, if it's on the inside, we do the what? So on the inside, we do the opposite, right? So if I just said 1/2 is a shrink for vertical, no, that means for horizontal, it's a stretch. But what can I do with this to simplify that? How do we simplify using exponents? No, not get rid of it, right? Just simplify it. Just remember here that this can be written as x squared over 2 squared, right? And all of a sudden now, instead of being horizontal, it's vertical. Right. So that's why this does get a little messy. And my main thing is going to be to show this one problem. But guess what? Don't get caught up in the messiness because our focus on this is getting the graph, right? So as I go talk about this graph and I'm saying, hey, I'm going to plug in some x values and get my j values back. The main point that we should be focused on right now is -1, -5. Are we good with where that's coming from? So let's go plug in then -2, -3, and then 0 and 1. And let's see what that stretch looks like. Okay. So as I do that, someone in your calculator, if you want, just start plugging into J for me and we'll get all those points. Hopefully you're using your calculator, learning how to use a calculator to do this quickly because you don't have to erase everything to type it all in again. Make sure though, as you're doing this, that you're practicing using your calculator yourself right now. Don't let it just be me doing it. I made these numbers fun apparently, right? But make sure you're getting 3 and -3 when you plug in those values. And also make sure you see the symmetry there, right? We should have expected symmetry still. It's still quadratic. So we shouldn't be surprised that I got 3 and -3 above that and then 3 and -3 below that the way we did. Okay. But at that, you didn't even have to go do anything except for, hey, I know a stretch is here. Now you have your points. Let's plot them out. So that would put us at -2, -3, 0, -3, and then what we said, -3, 3, and 1, 3. Okay. And then we can draw our graph from there. But hopefully what you see is that kind of narrow, it's still that U shape, right? But it's just narrower. All right. If drawing this by hand, would I expect perfection? No, it should be somewhat accurate, but not perfection. No, so when with yours, you have that TI, the 30, right? So let's go to a new screen. Make sure I copy this down correctly. Is that what we have? So when you go to your calculator, the way I recommend doing is doing 2 parenthesis, plug in the number you're working on. So like you said, we're doing -3 first. Okay. Then close the parenthesis there. That way you're highlighting what you plugged in. And then do +1, close parenthesis. Your caret key should look like that. Or you can hit your squared button is fine here. But sometimes, like I said, we're gonna have cube or other exponents. And then put -5 and hit equals. You got 3. Now, what you do is you use those arrows. If I think right, if you hit the right arrow, it should put you to highlighting this 2. And you could click over here and change that -3 to -2. Right? That way you can get them all done quick. That's why I'm saying, like, I want us to be able to graph just knowing the transformations, but I also know that when it comes to dealing with stretches, that's where we get messy, right? And that confidence of being able to say, hey, now we know how to get to these points. Now we know how to make sure we know these points, right? Also, remember, as we've kind of talked about, expect to see symmetry here. It's not even now because even is symmetrical to the y-axis, but there's still symmetry with the quadratic. Okay. With that said, if I go to the left 2, how far did I end up going? So what's the difference between that y value, which what we see over here, +3, sorry, and -5? What is that difference? Okay. What is the difference? What is 3 minus -5?
Is it 3?
3 minus -5. What's the difference between them, right? It's 8. Is 8 random when we talk about a quadratic? That's the question. Well, what was our factor that we just said we're stretching by? 2. So what we see here, this is 8, but 8 equals 2 times what number? 4, right? Well, hey, there's that number that we actually were expecting is the 4. Okay. That when we square 2, we get 4. So it's still there, but know that we see the factor taking place. We went up by 8 because that's 2 times 4. So if we went one more point, we would have to go up not 9, but 18, which at this point, we're not even going to bother trying to graph because that's going to put us up at what? 13? Okay. Are we good though with where the approach to getting these points is, where I'm getting that perspective from? Now, if you get confident with your transformations, remember, all you had to do is go, hey, if I go over 2, I don't want to go up 4 once, but I need to go up 4 twice. That's where we can come from there. The same is if I go to the right 1, I need to go up 1, now a single time, but twice, because I multiplied by a factor of 2. Okay, so that's kind of another way to look at it. All right. But the good news is, with a little bit of extra work, it doesn't take us too much longer, and especially if we get comfortable with our calculator, it really doesn't take that much longer. We should know what graph to expect, but that will help us make sure we get the correct graph. We feel okay with that? Is there any concerns with using the calculator that we just talked about? If you have a different calculator, well, it's an illegal calculator, right? So just keep that in mind, right? Anybody know what I'm talking about? All right. Now to remember what I was supposed to talk about. Do we feel okay with the graphing though? Just kind of going what we did, or is there anything I could help someone feel more confident about? All right, let's go do these problems then, just for the fun of it. All right. It actually works out that you already wrote them down. Some of y'all probably did these sections. Man. Some of y'all might have done the next section, so it works out.
Yeah.
Not from our class, by the way, but hey, since they're there, let's do it. All right.
Yeah.
The cool part is I could take a lesson I did in another class and make sure to squeeze it in today. Now, before I do this though, do we feel okay with that graphing perspective? Is there any concerns? All right, what you're going to see there, that's called graphing with transformations. All right, the graphing linears, hopefully we practice that. If you have questions about slope and intercept, please let me know. Other functions, we like to use transformations, but just keep in mind, all those only had one x. There was only one x that we were working with, and it was one major operation as far as like square root, squared, absolute value. The others were just addition, subtraction, and multiplication. The second we start mixing stuff, we can't do that. For example, like if these were functions, I wouldn't be able to use transformations. I got a bunch of variables for each of them. Okay. Was there a question though? I saw a hand. All right. Now, as we work with functions, we've kind of talked about combining functions in different ways. So understand that as you finish up writing these down again, sorry. This was one example that we looked at, like as far as combining functions together for different purposes. If you remember, the first thing I did with that one looked like this. Let me go find it again. I know we did one, y'all. There we go. This was one good example that shows we could take one function and bring another function in with it. Okay. So the good news is we've kind of talked about some of the stuff that we need to move into next, because I felt like it helped us get to this situation here. I felt like it was a good bridge to the difference quotient. All right. So what you're going to see here is we want to continue kind of what we talked about in some of these perspectives. Now, what you're going to find is here, as I go back to this over here, do these two have really anything in common? Right? I didn't do x plus h or anything. What I did is like, here's one polynomial, here's another polynomial. Let's just see what happens when we subtract. Does everyone follow that? So how do I go about subtracting two functions? What's one thing we need to remember to do? Very good. That's going to be the main thing. As you see here, the parentheses are kind of important, right? Technically, I didn't need it on the first one. But that second one's very important, because as we talk about the difference quotient, I'm not subtracting one term, I'm subtracting all of them. With that in place, though, what in the world do I do now? There's going to be a little bit more going on here, though, right? Technically, some terms could technically, like we talk about, drop out because they go to zero, cancel out, but that's not always going to happen. The difference quotient, however, make sure you see that those terms should cancel out. Right? All we should have left in the numerator is something with h. If we don't, then we did something wrong. But here we should have what, 3x to the fourth Yep. You said 7x squared, right? I should highlight what I'm doing. So we had x squared in common, nothing else. No, the constant term, huh? This is definitely one area though where you do want to take your, I'm not about to write it again. You said -6, right? You have to have a way though to filter through this, right? Not every problem is going to have this many terms, but I felt that was a good, like, hey, here's one polynomial function. What happens when I subtract another one? I didn't put it in function notation though. I put it just as, let's focus on the subtraction. Okay. Some of you probably did that already, so no big deal, but are we okay with that one as far as the subtraction? What's going on with the next one though? Distribute, right? So we're here now focused on multiplication, right? Now, I'm just making this one up though, for the sake of make sure we're comfortable with distribution. But also remember that when we're done distributing, what do we have to remember to do? Right? That when we do multiplication, right, oftentimes I'm going to have to combine like terms when I'm done. Okay. That after I do all that, the next step is to make sure we go into the combining of like terms. Now, does the order I write this in really matter? As long as the correct signs matter. However, what was the order that I say to always encourage you to do? Mm-hmm. So as we look at these two, if we're going down, right, we're putting in what order? What's descending order is the way I would say that. Based on exponents, right? I know we kind of talked about that as far as the equations, because like if I gave you x cubed, it was helpful to have it in that order for factoring purposes. Try to keep that in mind. I have a -3 to -8, so it's gonna be negative. I'm talking about right here, correct? We had a negative times a positive, so that's what affected the 8 there. And if you like to highlight again, that's one way to make sure we get all our like terms together. Okay. Now that's me, just like I said, making sure we practice the distribution. But what am I doing with these functions here? But FOIL means multiplication, though, right? Make sure you see here, hey, let's multiply two functions together. Okay, I think I gave you the first one, not the second one, right? But when I start multiplying functions, remember FOIL helps us, but also make sure you go back to the fact that this is just distribution. FOIL is a helpful acronym to remember that, but always go back and remind yourself, hey, that just means distribute. Here, however, we have to distribute not once, but twice. So are we okay if I put that for this next step? Now, one thing you're going to find here, though, is when I'm doing this, I'm probably going to have some like terms once again to combine. But that's not always going to happen. Oops. All right. Do we feel okay with that first one? It's kind of a mix of review, right? We've done some of this, but I want to make sure we're confident with it, right? That's one step we're taking as far as just, hey, as we go back over this, let's remind ourselves some of the things that we have talked about. But the second one, I don't think we really ever multiplied. I might have did an example with the test to show you that there was a special multiplication that we can get. All right. But make sure you see here, it doesn't change the process of distribution. However, it changes the result of what we're getting. Because after I do the multiplication, what do I need to do? Are there any like terms to combine though? No, it just happened to be, hey, it worked out nicer, right? So keep that in mind. Now we'll have some other multiplications that we look at. I think one of the examples is like what we see here, but we've talked about that a little bit, and I'll do that more later. But I want to make sure to connect this back to where we're going with this. Okay. So this is a good example of what we're going to be seeing moving forward. What did I do differently about this one? What is f of x and g of x though? What is that called? Two different what though? Functions, right? I use function notation, right? Now, what you're going to find is we got to get used to some new notation because we have a handy, what is going on? We have a handy way of writing this. So just kind of to introduce it, a more compressed notation. Because guess what? If you take a function, you subtract the function, we get a function. Now, is this the same function as these first two? No, right? It's a different function. It's its own function, right? Does everyone see that? But it's still a function. So we'll use like special notation, but make sure you see here with this notation, it's still f minus g, which means make sure we put what function first? And when I do this subtraction, I have to get to remember, just as we talked about before, to put those parentheses, right? That's one thing that we want to stress here. So that gives us what? X squared minus 7x plus 3. What? Minus 16 plus x squared? The only difference I did here is I made you plug in the functions where they belong, and that's what we're going to end up having to do as we go through this, okay? But we do want to be careful with that negative, though, because here we should get 2x squared, but if you're not careful, you might have no x squared. You might have dropped that out to 0, okay? So that's why we definitely want to be careful with that subtraction. We're okay with where I'm coming from for that? All right, so the only other thing we have to combine here looks like what the 3 and this. Did I use 3 and 16 again? No, it was something else. So minus 7x, and what's that gonna be? Minus 13? Now, what I hope you find is that means there's a section here. It's going to be a little work involved, but hopefully you get reassurance like, okay, at least we know how to do this. It's just making sure to set it up correctly. All right. So when you get to this one, what is it? Sections 2.6 and 2.7. 2.6 is going to be a lot of, hey, I need to remember to multiply correctly, combine like terms correctly, but make sure you recognize the notation. Okay. So as I deal with this one here, if I pull this aside a little bit, oops. If I wrote this out, what would it mean? What's it telling me to do? Huh? But it's just subtraction now, right? Does everyone see that? I just wrote that. I'm sorry. What if I did that?
Yeah.
You add them together, right? So does everyone see? That's what I should have wrote at the beginning with. What if I wrote like this, though? It's multiplication. Now, what do you need to have when you write out the multiplication? Parentheses, right? What goes in the numerator, though? Right, so F goes up top, G goes down, right? Now, be careful, though, as we deal with this. One thing you're going to start to find as we practice this is we're creating a new function, right? So both of these were polynomial function specific quadratics, which, hey, domain was all real numbers, but make sure you see here that when we start doing this, we got to be careful, right? Because now it's going to be rational, and that might have an impact on what we're working with. So that'll be one thing we talk about. But are there any concerns about like, hey, addition, subtraction, multiplication, division? And we all feel okay with just kind of the combining like terms and the multiplication I kind of reviewed today? All right, so what I would say is we go from there, what we'll build on, just so you can see. This would be a good example of what we're going to build on it, is make sure you first recognize what you're working with, be able to find and simplify what you're working with. But one of the important things is always make sure you keep an eye on the domains. Okay, so this will be one we do on Monday. Like I said, tomorrow I'm gonna have that special situation. Just be prepared. I'm gonna give you a little, like I think I did at the beginning of the year, right? Here's a little paper quiz. Right on it. I'm not making this a high stakes situation. It's more about practicing and making sure you're comfortable with what to expect on the test. Is that clear to everyone? But as you see here, just keep that in mind as you go through the weekend. And thinking about ahead of time, it's like, hey, as I look at it, identify what you're working with, know how to get the domain of what you're working with, and know that moving forward, when we start doing stuff, that's one of the questions that we're going to refer back to. Okay, what is the domain now? Okay, any questions or concerns though with the actual operations of adding or multiplying, subtracting? All right, we'll do the division more though. I feel like that's one that we spend some time on, so keep that in mind. But if you have no questions, have a good day, and I will be here tomorrow for 10, but just know I have to leave early. Wait, don't go yet. What'd I forget to do?